Hello everyone, so now we moved on to example 4. In this, we're going to do our chain rule with a quotient rule. So as we can see, I have my fractions, which means I would have a quotient rule because I'm dividing. But I also have this built into the bottom, which is where my chain would come in. So we're going to approach this like a quotient rule, except when I take the derivative of my bottom, I have to look for a chain rule as well. So I'm going to have y prime is equal to my bottom times the derivative of my top, which is just 2, subtract my top times the derivative of the bottom. And the derivative of the bottom would be I bring my 2 down front, times 4 minus 5x to the power of 1, times the derivative of my inside, which would be negative 5. And that's all over my denominator squared. So right now it's already squared. If I squared something that's already squared, that would make it to the power of 4 because I would multiply those two exponents together. So now I have y prime equals 2 times 4 minus 5x squared. And I'm going to start simplifying this second part over here. So I have negative 2x times positive 2, which is negative 4x. And then I have that times negative 5. So negative 4x times negative 5 is positive 20x. And then my denominator is still going to stay the same. Oops, I forgot this up here. So if I look at this, I do have a GCF between the both of them. I notice that I have a 2 that they both can go in. And I also have a 4 minus 5x. So left behind for my first one would be 4 subtract 5x plus 10x. So this is still divided by 4 minus 5x to the power of 4. But now I can start simplifying things out. So since I'm multiplying, I can cancel this with one of these exponents and change that to a 3. So now I have 2 times whatever's on the inside, which is 4 plus 5x, negative 5x plus 10x, all over 4 minus 5x to the power of 3. So we're done here. If you want to, you can bring that 2 in, and you would have 8 plus 10x all over 4 minus 5x